Welcome to this video where we will see top 23 interesting facts about Neutron Star. So, actually what is a neutron star? A neutron star is the collapsed core of a giant star which before collapse had a total mass of between 10 and 29 solar masses. Neutron stars are the smallest and densest stars, not counting black holes, hypothetical white holes, quark stars, and strange stars. Neutron stars have a radius on the order of 10 kilometers, 6.2 miles, and a mass of about 1.4 solar masses. They result from the supernova explosion of a massive star, combined with gravitational collapse, that compresses the core past white dwarf star density to that of atomic nuclei. Simply put, a neutron star is the collapsed and highly compressed remains of a relatively massive star that died in a supernova event. Neutron stars are also the smallest stars known to exist, with their typical radius being only about 10 to 20 kilometers, and weighing on average about twice as much as the Sun. Below are 10 more interesting facts about neutron stars you may not have known. Fact 1. Most neutron stars are very fast rotators. Since the conservation of angular momentum following a supernova explosion transfers the progenitor star's rate of rotation to the remnant that is only about 20 kilometers, 12.5 miles, in diameter, the result is that the neutron star rotates very rapidly when it is formed. Most known neutron stars rotate several hundred times per second, but the fastest rotator yet discovered, the neutron star designated, is known to rotate 716 times per second, which translates into 43,000 rotations per minute, or 24% of the speed of light at the star's equatorial surface. Fact 2. Neutron stars are very hot, and very dense. Neutron stars that can be observed are typically very hot, with surface temperatures that can be as high as 60,000 K, compared to say around 6,000 K for the Sun. The density of neutron stars decreases as their diameters increase. Fact 3. Neutron stars are not very massive. Despite their very high densities, neutron stars are limited to between 1.1 and 3 solar masses, with the most massive observed weighing only 2.1 times as much as the Sun. Fact 4. The Milky Way has about 100 million neutron stars. The figure of 100 million is based on standard models of galactic evolution, and is further derived from the estimated number of supernova events that have occurred in the history of the Milky Way galaxy. Fact 5. Neutron stars and pulsars are often the same thing. All neutron stars have extremely strong magnetic fields, typically in the order of 104 to 1011 teslas, which is several billion times stronger than Earth's magnetic field of only 25 to 65 microteslas. It is thought that the magnetic pulses given off by some neutron stars result from large build-ups of electrostatic fields near the star's magnetic poles. Fact 6. Neutron stars are powerful gravitational lenses. While all massive objects are known to be able to bend light rays, neutron stars take this to a whole new level. On average, the gravitational field of a neutron star is about 200 billion times stronger than that of the Earth, which means that the light emitted from the side of a neutron star that faces away from us, is bent to the point where parts of the normally invisible side of the star becomes visible. Fact 7. Neutron stars can spin up, and then down again. In cases where a neutron star accretes matter from a normal companion, the matter is sucked up like a sponge, which can increase a neutron star's rate of rotation by as much as 100 revolutions per second in the case of millisecond pulsars. Fact 8. Neutron stars can host planets. At least 2 neutron stars are known to have planets, although the origin of these planets is not certain. It is thought that in some cases, the planets may be original, in the sense that they survived the formation of the neutron star, or that they may have been captured. Fact 9. Time dilation between Earth and a neutron star is measurable. Due to the exceedingly high gravity on a neutron star, the difference in time displayed between identical atomic clocks placed on the star and Earth would be significant. Fact 10. New neutron stars cool down fairly rapidly. While the temperature inside a newly formed neutron star is estimated to be around 10 billion Kelvin, the newly formed neutron star emits so many neutrinos that much of this heat is carried away by the escaping neutrinos. Fact 11. Neutron stars are formed from stars that has initial mass of at least 8 solar masses, m, as main sequence stars. Fact 12. Over billions of years, these massive stars burn out their fuel, leaving behind a white dwarf star that features a core rich in iron. At this stage, the electron degeneracy pressure at the core tries to balance out the inward gravitational pull of the dense mass. Fact 13. In fact, scientists say that kind of mass is packed within a diameter of 24 to 26 kilometers. If someone somehow manages to scoop out a matchbox full of matter from neutron star, the weight of the matchbox will be nearly 5 trillion tons. Put in Earth's perspective, about 1,000 cubic kilometers of rock on Earth weighs 5 trillion tons. Fact 14. Because of the extreme mass of neutron stars, they have surface gravity higher than that of Earth by 1011 times. That is, 100 billion times higher gravity than Earth. With such high gravity, the escape velocity of a neutron star ranges between 100,000 to 150,000 kilometers per second. This is anywhere between 1/3 and 1/2 the speed of light, which 300,000 kilometers per second. Fact 15. As far as the structure of a neutron star is concerned, current mathematical models estimate that a typical neutron star has 4 layers: outer crust, outer core and inner core. Outer crust has a thickness between 0.3 and 0.5 kilometers. It is made up of electrons and ions. Inner crust has a thickness between 1 and 2 kilometers. It is made up of nuclei, neutrons, and electrons. Outer core has a thickness of approximately 9 kilometers. It is made up of neutron-proton Fermi liquid and a few percentage of electron Fermi gas. Inner core has a thickness between 0 and 3 kilometers. It is thought that the inner core is made up of quark gluon plasma. Fact 16. There are different variants of neutron stars available. The most popular ones are pulsars and magnetars. Again, there are hypothetical variations like quark star, electroweak star, and preon star. Fact 17. As of now, scientists estimate that there are 2,000 neutron stars in our Milky Way galaxy, and most of them are radio pulsars. The most massive of all known neutron stars so far is PSR J0348-1432, which is estimated to have a density of 2.01 plus 0.04 m or 2.01 to 0.04 m. Facts 18. The closest neutron star, the one that the closest to our Earth, is PSR J0108-1431 and sits at a distance of 130 parsecs, which is equal to 424 light-years. Fact 19. Neutron stars that can be observed are very hot and typically have a surface temperature of around 600,000 K. Fact 20. They are so dense that a normal-sized matchbox containing neutron star material would have a weight of approximately 3 billion metric tons, the same weight as a 0.5 cubic kilometer chunk of the Earth, a cube with edges of about 800 meters, from Earth's surface. Fact 21. Their magnetic fields are between 108 and 1015, 100 million to 1 quadrillion, times stronger than Earth's magnetic field. The gravitational field at the neutron star's surface is about 2 times 1011, 200 billion, times that of Earth's gravitational field. Fact 22. The temperature inside a newly formed neutron star is from around 1011 to 1012 Kelvin. However, the huge number of neutrinos it emits carry away so much energy that the temperature of an isolated neutron star falls within a few years to around 106 Kelvin. At this lower temperature, most of the light generated by a neutron star is in X-rays. Fact 23. Current models indicate that matter at the surface of a neutron star is composed of ordinary atomic nuclei crushed into a solid lattice with a sea of electrons flowing through the gaps between them. It is possible that the nuclei at the surface are iron, due to iron's high binding energy per nucleon. Fact 24. Neutron stars are detected from their electromagnetic radiation. Neutron stars are usually observed to pulse radio waves and other electromagnetic radiation, and neutron stars observed with pulses are called pulsars. These were some of the interesting facts of the neutron stars. Subscribe and hit the bell icon for more updates. Thank you.